In this lesson, we're going to look at another data structure, the binary search tree, which is a specific type of a binary tree. I pulled up the Wikipedia page for binary search tree so that you can see a diagram of what a binary search tree looks like. Binary search trees are made up of nodes, parent nodes and child nodes. A parent node will have two child nodes, a left node and a right node, and that's all. That's the binary part of the tree. The first node in the tree is called the root node, number 8 here, and 3 and 10 are the left child and the right child of the root. The root node does not have a parent node, but has two child nodes, but other child nodes can have parent nodes, such as 1 and 6 have the parent 3, 13 has the parent 14, 14 has the parent 10. Oh, I should also mention that binary search trees have a property that make it very easy to find the minimum and maximum values of a tree. We're going to explore that feature in the exercises. So let's see how to create binary search trees in Java. So the first thing we're going to do is we want to create a node class. So we'll start off public class node. We're going to use all integer data for this example to keep things simple. So our first field will be the data field, which is integer. Then we create left and right child nodes. So those are the other two fields of the class. Next, we're going to create a constructor, which takes one parameter, and we assign it to the data field. And then we assign null to the left and right child nodes because they will be assigned values through the insertion process, which we'll look at in just a moment. We'll also create a default constructor right there. And then finally, we'll write a getData method to retrieve data from a node. So let's exit and save. Then let's compile it just to make sure everything is working fine. Okay, so now we're ready to build our binary search tree class. So we'll call this program binarysearchtree.java. The only field we're going to define is the root node, and we'll make it public so that we have easy access to it. So we'll declare it first. Then we'll create our constructor, which will simply assign the root node null, the null value, and then it will get assigned data later. Now let's define an insert method. So to insert a new node, the first thing we do is create a new node. Then we assign the data to the node, like so. Then we check to see if the root is null. And if the root is null, then that means we're creating a new binary search tree, and the new node becomes the root because it's the first node being inserted. The first node inserted is always the root. Otherwise, we create a node called current and assign it to be the root. Then we create a parent node, and these are all just temporary values. Then we set up a loop that will run until we break it, set the parent equal to the current. Then if the data that we're trying to insert is less than the data that's stored in the current node, then we want to move to the left. If you remember how the binary search tree was set up, lesser values go to the left. And if the current node is null, then we're going to set the value of the left child of the parent to the new node and then break. Otherwise, if the data is not less than, then it must be equal to or greater than. So in that case, we're going to go to the right, like so. Check to see if the current node is null. What that means is that there hasn't been any data assigned to it yet. And then we assign data to the right child of the parent, and then we break. So we close off the if, close off the else, close off the while. Hope I get these lined up. Close off the other else, and then close off the insert method. and then close off the class. So we'll know here in a moment if I got all those braces correct, as we're going to compile. And I did, surprised a little bit. So we're going to learn how to traverse a binary search tree and check minimum and maximum values in the exercises. But let me do one more thing before we end this lesson. Let's just create a program that we're going to flesh out in the exercises. So what I'm doing is I'm creating a new binary search tree object. Then we're going to insert a few values. And what I want to do is I want to compile this just to make sure that everything's working correctly. And then when we get to the exercises a bit later, we'll learn about traversals and finding minimum and maximum values. There will be no output from this, but we'll run it anyway. Make sure we don't have any runtime errors. And we don't. So that's how we create a binary search tree. It's really just a matter of moving to the left or right down a set of nodes until you get to a null node and then inserting the data at that point based on whether you're going to a left child or a right child, and that depends on the value of the data compared to the value of the data in a current node. So with that, we're finished with this lesson, and we'll come back to binary search trees again in the exercises.